So in the last two classes, we discussed what is operating system, the different functionalities of operating system, and why operating system is called as a resource manager in computer system. So that we have discussed. Now, what is the need of manager? What is the rationale behind the managing resources? That we discussed. Now, in a very nutshell, again, in one or two sentences, I will try to wrap up why resource management is one of the requirement factors for multiprocessing or process execution environment. I mean, to execute process. So if you have 4 GB or 8 GB RAM and you are happy with executing only one program, then the entire 4 GB or 8 GB RAM can be used for executing of a single process. Similarly, if you have a single processor and that processor is only used to execute one program or process at a time, then you don't need much complicated operating system, because once you have a processor and that processor is always free just to run a single program. But today our requirement has changed a lot. Today we are not happy just by executing only one program at a time. Rather, the moment we start our machine, we want that 456 program or 456 application will be executed concurrently. Concurrently means all will be executed simultaneously in the system and we will be getting the output. For example, you are in one tab or one browser you are working with.
Sir, one question, sir. Are you still on the first slide or are you changing the slide, sir?
No, I'm still in the first slide.
Yes, sir.
Still in the first slide.
Okay, sir. Thank you, sir.
So you have a one processor, and within that processor you are trying to execute a browser which is running a Facebook. Maybe in another browser or another tab of the browser you are running WhatsApp. Parallelly you are listening music through VLC player. Parallelly you are writing code in one of the maybe programming environment. So you see, at a time you are working with 4, 5, 6 application simultaneously in your system. Now the question is, if you have a one processor system or uniprocessor system or even dual processor system, then how this one or two processor will be used to execute 4 or 5 or 6 programs simultaneously? And that is the need of processor management or process management. How efficiently operating system will manage your computing resource, or we can say the CPU cycle. How efficiently the operating system will manage the CPU cycle to execute that concurrently 5, 6, 7 program. Okay, so that are the entire discussion of under the process management and process. Okay, on the other hand, any program to be executed or any instruction to be executed by the CPU, that instruction or the program must be loaded in the main memory. And CPU can execute one instruction at a time. After going through the computer organization subjects, you are much familiar with the idea that a single CPU can execute a single instruction at a time. No two instructions can be executed at a time. So if you have a single CPU in your machine, from this we can infer that if a CPU can execute one instruction at a time, so we can say a CPU can execute one program at a time. You may have multiple programs. You may submit multiple programs at a time, 4, 5, 6 programs at a time to the system for execution. But CPU can execute only one program at a time. Then why we are saying that it is a multi-programming environment, or why we feel that whatever program we are submitting to the system, 4, 5, 6 program, all are getting executed simultaneously. Is the question clear, or is the idea clear? What I want to mean?
Yes, sir.
Yes, sir.
So at a time CPU can execute one program. Now we have submitted 4, 5, 6 program together, and we are expecting that all these 4, 5, 6 program will be executed simultaneously. Then the next question will be coming that how a single program, a single CPU or a dual CPU is or are executing 5, 6 programs simultaneously. So there is some mechanism with which we feel that all my 5, 6 programs are being executed simultaneously. So that will be the discussion of today's class. Okay? Now what is process? Sorry. দেখো এবার slide change করছি যাচ্ছে
Yes, sir.
Yes, sir. Yes.
Yes, sir.
Okay, so we will be discussing process concept. What is process? Then process scheduling, operation on processes, cooperating process, inter-process communication, and some other applications like client server system and all. Now what is process? কেউ বলতে পারো what is process? What is the difference between a process and a program?
Process is the solving of the program.
The process
No, not exactly.
execution.
Sir, any task,
Execution.
বলো প্রজেক্ট কি বলছো?
sir, any task, sir, any task, like irrespective of whether it's a program or not, sir.
और कुछ?
So
तुम्हारे-
Sir, when we provide a runtime environment to a program, then it becomes a process.
क्या करम क्या बोल रहे हो?
Sir, when we provide a runtime environment to a program, it becomes a process.
Good. When you provide a runtime environment to a program, it's called a process. Good, very good. So, in other way, we can say a program in execution is a process. A program in execution state is a process. So, you can write a program in your in an editor, maybe Notepad or maybe in whatever editor you can write a program, C program or C++ program or Python program. After writing the program, you can save it to a file, and then you can keep that file in your pen drive, or maybe in your disk, or maybe in your somewhere else. You can carry that pen drive and put it in one machine and give the command for execution. Then operating system will load or copy this program from your secondary disk, maybe pen drive, CD or whatever, to the main memory, and CPU will start executing it. That state of execution is called a process. So that's why program is a passive entity. Program is a passive entity. Why it is a passive entity? Because you can write a program and save it in your pen drive. You can write a program, you can save that program in your copy. But while you submit this program, that set of instruction to the system for execution, you will be calling it as a process. So again, from the beginning, if we start defining, a program is a set of instruction written in some programming language. Program is a set of instruction written in some programming language. Set of executable instruction. A program is a set of executable instruction written in some programming language. It can be Java, it can be Python, it can be C++, whatever. So a program is a set of instruction or executable instruction written in some programming language. After writing the program, you can save it in a file and keep the file in your pen drive, in your disk, in your pocket, in your copy, whatever, wherever you want. That doesn't mean it is in an execution state. While you submit this program to the system for execution, that state is called a process. That's why process is an active entity. It is an active entity, whereas program is a passive entity. Now, process and job and process and tasks they are used interchangeably. Sometimes you can say it is a job or it can be said as a process. Both are same. But process and job are same. They are execution mode of the program, whereas the program is a passive entity. It is a set of instruction. No resource, nothing. Bolo. Is the idea clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Good. So you have a program. You have a program that means set of instruction. Maybe you have saved in a file .cpp or .py or whatever .jv or whatever. With that program, you insert it in your machine and give proper instruction or command to execute that program. Then that program will be loaded in the main memory for execution by the CPU. So if you have a 100-line program, maybe a 100-line or 1,000-line program, the instructions of the program will be executed by the CPU one at a time. And while it executes, the program will have program counter, stack, data section. I think you are familiar with the term program counter. Have you heard the term?
Yes, sir.
I think you have heard the term accumulator.
Yes, sir.
Yes, sir.
Okay, good.
Yes, sir.
So, while the program you submitted to the system for execution, a memory block will be created. That means in a 4 GB RAM or 8 GB RAM, a space will be created for that particular program. And it typically looks like this: text, data, heap, some other data structure, stack. Sure, this is the allocation of the program you have submitted to the system. And this allocation is in the memory. So if you have 5 program or 6 program, so all the 5 and or 6 program will be copied in the main memory in this way. So that means 5 or 6 block, one for each process, will be there in the physical real memory. It starts with text, data, heap, some other data structure, stack. Now why? I will be coming one by one. Before that, now another thing will be created that is called process control block. The way when you after clearing your joint entrance exam, when you take admission in NIT Durgapur, for each of the student there is a personal file associated with you, which consists of your name, your parents' name, your maybe joint entrance exam details, from which state you have come from, your address, present address, permanent address, your date of birth, your phone number, parents' phone number, and the branch you took admission, and first semester, etc., etc. So this is a file, or this is kind of, you can say it is a personal diary or personal file for each of the student. Now there are some information in that personal file which gets modified in each semester. There are some information on that personal file which are fixed throughout your life. For example, your name, your parents' name, your date of birth, your registration number, your roll number, these are some fixed informations. But the first semester you may took admission in electrical engineering, but after the second semester you may be what is called slided to some higher level or higher branches as per your choice. Maybe you have shifted to computer science or electronics. So your branch gets changed. Your CGPA value may, of course, it will be changed from first semester to second semester, from second semester to third semester to fourth semester. Your present address may be changed. But there are informations like roll number, registration number, parents' name, etc., etc. They will be fixed for the entire lifetime. The roll number that I had in my time, this roll number will not be given to anybody else. There is a particular nomenclature for the roll number. So this time you have also nomenclature. Our time also we have some nomenclature. 98 by 419. So it tells the year I took the admission, 98. 419 is the roll number of that particular batch. Similarly, these days also you have a nomenclature. 20, then slash, then CS, then this, and this. Which imply you took admission in 2020, your branch is CS, and your exact value of the roll number is maybe 120. In the same way, when a process is created, that means when you submit a program for execution, in the same way when you submit a program for execution, a process control block, just like your personal diary, will be created, and that will be maintained by the operating system. Just like your academic file is maintained by the academic section of the institute, in the same way, a process control block for each process will be maintained by the operating system. These informations are process state, program counter value, the values of CPU registers, CPU scheduling information, memory management information, accounting information, IO status information. So if you have, suppose there are 7 simultaneously executing program in your system, so there will be 7 PCB, one for each process. If the NIT Durgapur has 5,000 students, so each student will have a separate academic personal file. Some of the information may be updated during the tenure of the course. In the same way, some of the information of the PCB will be changed during the lifetime of the process. Is the analogy clear?
Yes, sir.
Any doubt? Follow.
No, sir.
Sir, what does the program counter does?
Yeah, I'll be coming. Sure. Follow. First, let me tell. Let me know whether this concept is clear or not. The PCB concept. Then I will be coming each one of these. What is program counter? Can anybody tell from your computer organization's point of view?
Sir, it holds the address of the next instruction to be executed.
Good. It holds the address of the next executable instruction, right? It holds the address of the next executable instruction. ठीक बोला था मैंने?
Yes, sir.
Yes, sir.
So program counter is a register. Program counter is a register that holds the address of next executable instruction. So what will be the next executable instruction? That will be kept track by the program counter. Can you name some CPU registers?
Sir, memory address register, memory data register.
And one of the important registers that you forgot.
Accumulator.
Instruction register, sir.
बोलो Karan क्या बोले?
Accumulator.
Accumulator. So what is the content in the accumulator?
So I think
Because what is the content of the accumulator?
Intermediate.
Accumulator save a result of LU.
so like all the states of the ALU, sir.
Sir, it holds the computed values which might be used in the future. So it holds it.
Not future, but it holds the
Results.
result temporarily. Current result temporarily. Of course, it holds the result, but before saving the result to some other place or in the memory, it holds the result temporarily. It holds the result temporarily. Do you agree this?
Yes, sir.
Yes, sir.
It holds the result temporarily before saving it to memory or somewhere else. So apart from that, there are CPU scheduling information, memory management information where the program is, program is copied in the main memory. Some accounting informations like the values of the data structure, some values changed during the execution, etc. Some IO status information. Suppose if you submit a program, that program may require different files as input. Suppose you have data in your secondary disk that you want to use by your program. So you have to open that file. Similarly, you have done some kind of computation and you want to store the result in a file. So there are some files which may be associated with the currently executing program. Now, what is the use of this? That we will be discussing with this. As I told you in the beginning of today's class, CPU can execute one instruction at a time. CPU can execute one instruction at a time. So in that analogy, we can bring that CPU can execute one program at a time? Yes or no?
Sir, could you repeat what you said, sir? I didn't
Yes, sir.
CPU can execute one instruction at a time.
Yes, sir.
Right?
Yes, sir.
So from there, can we say CPU can execute one program at a time?
No, sir, because in
No,
case
sir.
one instruction have input-output requirement, then it will go to the waiting state according to this given diagram.
No, you don't. We don't consider the given diagram right now.
Okay.
I'll be coming. I'll be coming to that.
Program is a set of instructions, so it has multiple instructions. So how can instructions at the same time? So I don't think this is right to say that it can execute a program.
Okay. So can I? So Kiti Srivastav, can I then say a CPU can execute multiple program at a time?
Sir, I don't think so. I mean, we'll require multiple processors.
I don't have. That is not my question. My question is, if I say a single CPU can execute one instruction at a time. A single CPU can execute one instruction at a time. Okay? So you may have multiple programs in the system, but if a single CPU can execute one instruction at a time, then of course we can say that CPU can execute only one program at a time.
Yes, sir.
Not more than one program.
Yes, sir.
मेरा बात समझ में आया अभी?
हाँ सर, आ गया. Yes, sir.
So you may submit multiple program, but CPU will execute one instruction at a time. That means CPU can execute one program at a time, not more than that. Right? Then how can we say that we have submitted 5-6 program and all are executing simultaneously? That is the question. So the answer of this question is, while you submit a program, a process is created, and this is called the new state. This is called the new state when a process is created. That means you submit a program to the system for execution. Program and its corresponding a process will be created. Process cases means its identification will be given, process ID, just like you have roll number or registration number. And a PCB will be created for that process. Process control block. Process control block is a data structure, which is a memory module. Process control block is a data structure which composed of different informations. What are the information? The informations are this. So you submit a program, a process will be created, process name will be given, and a PCB will be created for that particular process. Okay? All the processes that are coming will be kept in this state, ready state. So ready state is nothing but it is a queue, ready queue, where all the processes are kept in a first come first served basis. So all the processes are created, newly created process will be brought in the ready queue in a first come first served basis. From the ready state, from the head of the ready queue, a process will be taken and will be sent to the running state. Running state means where the CPU is executing the process. or CPU is executing the instruction. During the execution, that particular program may require some input-output device. For example, in your program code, it needs to take an input from the keyboard. So that program will be that execution will be waiting for an input from the keyboard, and it will go to waiting state. So the execution of the program will be halted till you give an input from the keyboard. Can you remember the yesterday's code, that scanf function? আমি আগের দিন বলেছিলাম?
Yes, sir. Yes, sir.
So the execution of the program will be halted. किसके लिए halt हो जाएगा? To get an input from the keyboard, and it will not be executed further till it receives an input from the keyboard. So it will be waiting till unless you give the input from the keyboard. So it will go to waiting state. When it is in the waiting state, the other process which was in the head of the ready queue, the other processes which are on the head of the ready queue will be taken and will be sent one at a time to the running state for execution. On the other hand, the process which was waiting for input-output device, once it gets the input-output device, that input from the input device, it will again come to ready state for further getting the CPU cycle. Follow? Is this channel clear? Is this path clear?
Sir, could you re-explain it once, sir? This last part, sir, the IO event wait and IO completion.
All the newly admitted processes are kept in the ready queue. Ready queue means it is a queue. Queue to tumra jano naki? Projito?
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
All you are familiar with the term queue. So all the incoming processes are kept in a queue. Queue means simply a line. It is a queue in the mess, hostel mess, for taking the ID dinner. Okay? So it is a queue. From the head of the ready queue, one process will be taken and will be sent to the CPU for execution. So running state is the actual CPU place where the CPU is executing the instruction. So while CPU is executing the instruction of a particular process, it comes across an input-output function. For example, scanf function. It comes across to a scanf function. I am taking an example of C program, simple. So the moment it comes across a scanf function, that scanf function will not be executed unless you give an input from the keyboard. So that means it needs a IO operation, or it is an IO event, input-output event. Is this idea clear?
Yes, sir.
So the process which was running will be sent to waiting state till it receives an input from the keyboard. So it will be in the waiting state till the input is given from the keyboard. On the other hand, you cannot keep the CPU free. So take a process from the head of the ready queue. Take a process from the head of the ready queue and send to the running state for execution. The process which was waiting for input from the keyboard, once it receives input from the keyboard will be sent to ready state for further getting the CPU cycle. Follow.
Sir, but if there are two programs, means then there is no input output operation as such, means there is no operations such that the program will be sent into the waiting state and both have to execute simultaneously. Then how does the operating system do this?
Okay. I'll be coming to that. I will come to that. Apart from, so this is one of the input. I discussed the issue of input device. Similarly, there could be some output device also. Suppose one program was running and it wants to access the printer. It wants the access of printer. Maybe through this command, it wants to print a 10-page printout, which may take 2 minutes time. So once it come across to that instruction, it will be sent to the waiting queue, waiting state, because it will be using the printer and it will be in the printing, that waiting state or IO operation state till it completes the execution of the printer device. Once the printing job is done, it will be again sent to ready state for further execution. Okay? I will be coming to Khiti. I will be coming to your term. Okay, don't worry. Next, okay. What is interrupt? The processes are kept in a ready queue. Now, there are some scheduling algorithm or scheduler. Instead of maintaining first come, first serve, it can maintain the idea of priority. Priority means you are staying with in the hostel with your senior. Maybe if you go to hall 4 or hall 5, you will find that third year and fourth year are staying in the same hostel. So it is a courtesy that if you go to the mess and if you are waiting, if you find your senior in the back, you normally give the place to the senior. So the idea is, if a low priority process is executed and high priority process come in the system, then the low priority process will be interrupted. The low priority process will be interrupted and will be sent. It will be forcibly stopped executing. It will be forcibly stopped executing and will be sent to ready state. And the high priority process will go to the running state. Again, I am repeating. While a high priority process come into the system, then the low priority executing process will be interrupted and will be sent back to ready state, and the high priority process will get executed. Once the high priority process gets executed, the low priority process will again come from ready state to running state. বলো বুঝতে পারলে?
Yes, sir.
Yes, sir.
Yes, sir.
So there are mainly three state, ready, running, and waiting state. Ready, running, and waiting state. Ready, running and waiting state. The change of state of the process from one state to another state, it happens so frequently that as a human eye, you cannot detect whether your process is in the ready state or running state or waiting state. As a result, the user feels that all my processes are in the running state, but actually all the processes are not in the running state. If you have one CPU in your machine, then only one process can be in the running state. The remaining processes, either it will be in the ready state or waiting state. If you have 4 CPU in your machine, then maximum 4 processes can be in the running state. The remaining processes will be either in the ready state or waiting state. But this change of state from ready to running or running to waiting, it happens so frequently. It happens so frequently that as a human eye cannot detect whether it is in a ready state or running state or waiting state. बोलो खिति तुम्हारा आंसर क्लियर हुआ या नहीं हुआ?
Yes, sir. And in case of equal priority programs, how does it handle that case?
I'll be coming. Surely I will be coming to that. বলো এই তোমাদের ব্যাচে কি কোনো মেয়ে স্টুডেন্ট নেই নাকি? তোমরা ইনঅ্যাক্টিভ মেয়েরা তোমাদের ব্যাচে? কম্পিউটার সায়েন্সের স্টুডেন্টরা তো ঝলমল করবে পুরো একদম। You don't have any girl student in your batch? Only some few students are always interacting with me. What about the other student? এই কয়েকদিনই শুধু ইন্টারাক্ট করে যাচ্ছে আমার সঙ্গে। বলো whether you understood or not this idea?
Yes, sir.
দেখি জিজ্ঞেস করি। বলো তনুপ্রিয়া। তনুপ্রিয়া, who is তনুপ্রিয়া? তনুপ্রিয়া। উজ্জ্বল সাহা। উজ্জ্বল সাহা।
Yes, sir.
বলো if there are n CPUs in your system, then how many process can be in the running state, how many process can be in the ready state, and how many process in the waiting state? Maximum how many process? বলো
Sir,
বিশাল মহা, হ্যাঁ বলো।
sir, in running, sir, it will be. Sir, n process.
My question is, there are n CPUs in your system. Then what is the maximum number of processes can be in the running state? What is the maximum number of processes can be in the ready state? What is the maximum number of processes can be in the waiting state?
Sir, in running state there will be n process.
Okay.
And sir, in waiting, I'm not sure, but n minus 1.
Annesha,
Yes, sir.
give me the answer.
Sir, running state there will be n processes, and waiting. In the running state there will be n processes since there are n CPUs. And in the waiting and ready there can be any number, like the number of processes that we submit for execution.
Good, very good. What about the ready?
Sir, same as the waiting. It depends on the number of processes that we have sent for execution.
So if you have n number of CPUs in your system, then maximum n number of processes can be in the running state. Of course, there could be many minimum, but maximum n number of processes can be in the running state. There is no such upper limit in ready and waiting state, because ready state is a queue. It can maintain any number of processes. Similarly, for waiting state, because if you have 5 IO devices in your system, maybe one printer, one keyboard, one monitor, maybe your webcam, so there will be 5 or 6, that many number of waiting queue will be there. Each queue is associated with one input-output device. So there will be one printer queue, there will be one monitor queue, there will be one webcam queue, there will be one mouthpiece queue, there will be one speaker queue, there will be one mouse queue, there will be one keyboard queue. And any number of processes can wait on this queue. But for running state, if there are n number of CPUs, then maximum n number of processes can be in the running state. Once the process is completed, it will be terminated. Terminated means that memory block that was created for that particular process, that is PCB, will be deleted from memory. That memory block, PCB, which was created for that particular process, will be deleted from the memory. I mean, that particular data structure will no more existence. Okay? Any doubt?
Sir, is there any upper limit on ready and waiting states if
as such there should not be any. Yeah, I understand. As such, there should not be any upper bound. Okay, because if you have five IO devices, so I mean you can send 100 files to print through your printer, but 100 files, only one file will be printed. The remaining 99 files will be kept in the printer queue. So there is no upper bound as such. One at a time will be printed out.
Sir, how do you create interrupt? I mean, how do you assign priority?
क्या बोलो अब्दुल बोलो?
How do you assign any priority to any process?
How do you assign priority in a process? Okay. See, so there is another process scheduling part that we will be discussing in the next consecutive classes. Okay, so either all the processes have the equal priority. Khiti, you also concentrate here. Your question will be answered. Yes. So either all the processes have the equal priority. That means you are not considering any priority on the process. Processes will be executed in a first come first serve basis. The other can be the processes may have priority. Normally, if it is a normal system, I mean the system that we are familiar with, this system have normally all the processes have the equal priority except some system process. For example, shutdown or reboot or init process. If you kill the init process, your system will be immediately shut down. Have you tried it?
No, sir.
Hey, I think you did not come across the Linux user group. Have you come across the Linux user group team? I think no. I mean, there is a club in the institute called Linux user group. Okay, so these people always do a lot of stuff with Linux and open source software. Okay, so people usually from the second semester onwards, they usually get interacted with this Linux user group team, particularly the computer science people. Anyway, so as this is a pandemic situation, so you did not get that chance. So this type of experiment you can do in your home also. For example, I mean, for Windows it can be done easily, or even Linux also. I mean, there are a lot of programs going on in your machine, and suddenly you put the shutdown command, shutdown instruction. Immediately that shutdown process will kill all the other processes, and this process will get the highest priority to be executed by the CPU. Similarly, the reboot. Reboot is also a process. Shutdown is a process. That process has the highest priority over any other process in the system. Okay, so these are some system processes. Apart from that, I mean, for our day-to-day activities, you can assign some priority on the process. For example, you have a server. That server is shared by student as well as faculty. Take an assumption. And the system administrator puts some kind of priority. What is the priority? If there is a process come from faculty, then that will be executed first. The student process will be kept in a ready queue. Once the faculty processes are getting executed, then only the processes of the student will be taken from the ready queue for execution. So this type of scheduling can be, of course, done. ঠিক আছে?
Yes, sir.
Yes, sir.
Now I will ask very important, I mean, very interesting questions. You have to answer this thing. Okay, because why I will be asking this question? Because you have already started computer organization and architecture. So I am very sure you should answer this thing. I told whenever a process is created, a PCB will be created for each process. And what is PCB? PCB is a data structure that keep up-to-date information of a process. PCB is a data structure that keep up-to-date information of a process. So if there are 10 processes concurrently running in your system, then there will be 10 such PCB in the computer. Okay. Now, if you have one CPU, then how many program counter will be there?
So one program.
Good. Very good. Very good. How many accumulator will be there?
One accumulator.
One. Set of register, CPU register, of course ALU and all. So set of CPU register will also be one if you have only one CPU. Yes?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So similarly, from there we can say if you have two CPU, then how many program counter will be there?
Two programs.
How many accumulator will be there?
Two accumulator.
Two accumulator. How many other CPU registers will be there? How many set of other CPU registers will be there?
Two CPU.
Two.
Register.
Two. Okay. So if this is the case, then how PCB, I mean, what is the purpose of PCB for executing multiple program or number of program which is much higher than of number of CPU you have? Suppose you have only one CPU in your machine. You have only one CPU in your machine, and you are going to execute 5 programs at a time. You have submitted 5 programs. You have submitted 5 programs at a time. So out of the 5 programs, 1 program will be in the running state. The remaining 4 programs will be either in a ready queue or in the waiting state. Now, how one set of CPU register is used to run all the 5 programs? Can anybody say? Is the question clear?
Yes, sir.
Yes, sir.
Bolo, what will be the answer?
Sir, multiple system, sir.
See, if you cannot give the answer, I don't bother. But you must try.
Sir, multiplexer system, sir.
No. How PCB is used? How PCB is used here?
PCB will be maintained for the running state process, and whenever the other processes will come, PCB will get updated.
और थोड़ा अच्छा से बोलो, Kriti. और थोड़ा सोचो. I mean, of course, you are in the right direction.
Sir, flip-flop system, sir. Multiple flip-flop systems with enable lines.
Now, what is that? What is the actual thing it should take place?
Yes.
Sir, the accumulator will store the result of the one running state, and then it sends back to the register. The PCB will be registered, and then from the ready state, it will come to the PC.
বলছো ঠিকঠাক, আরেকটু better way তে বলো, আব্দুল.
Sir,
Abdul, of course you and Kriti are in a right direction. थोड़ा और मतलब logically you try to connect the thing.
স্যার যখন রানিং স্টেটে একটা প্রসেস চলবে, সেটা যখন কমপ্লিট হলো তখন ওটা অ্যাকুমুলেটরে স্টোর করবে পিসিবিটা।
See, I will not give the answer today. I will not give the exact answer today, but I'm giving you some more insight of it. Right? See, listen very carefully. This is a very fundamental thing. I told you that you don't need to study anything in a hostel or in a residence if you attend my class. So be rest assured about it. Please try to be with me. Suppose you have only one CPU. Listen very carefully. You have only one CPU. So one CPU matlab one accumulator, one program counter, one set of CPU registers. So while a process is running, I mean one process is in the running state, one process is in the running state. So the registers of the CPU registers of that particular CPU will be occupied by the information of that running process. Yes or no?
Yes, sir.
Yes, sir.
All you could understand what I told?
Yes, sir. Yes, sir.
Because you have only one set of CPU registers. That CPU registers are occupied by the information of currently running process. The moment that running process goes from running state to waiting state, the other process which was in the head of the ready queue will be coming to the running state. So that set of registers will be occupied by the information of the newly coming process. So of course the previous information of the previous process will be deleted because it goes to waiting state. But this process will again come from waiting state to ready state and again from ready to running state. So how you store that information of the earlier process?
Sir, is it stored in the stack?
আমি বলবো না।
Sir, information in the sense after running the intermediate information that is computed.
क्या बोलो चरण?
Mean the information you're asking that what will be stored means when it is in the running state, the intermediate results which are computed, those results have to be stored. That information you're talking about, no, sir?
I'm talking about that information, but here how PCB is helping, or what is the function of PCB here?
Sir, when program is in the waiting state and it has to execute again, then PCB holds the input which it is going to give further.
কি বলো পরিষ্কার ইংরেজিটা বলো, নাহলে বাংলায় বলো, কি বলছো তুমি তোমার মাতৃভাষায় বলো।
Sir,
yes, of course.
language
is not the important. The concept is more important for me. For me, the language is not the important. The concept is more important. Okay, bolo.
Sir, I don't speak Bengali actually.
You are doctor anyway, so.
I'm from Nepal, so that's why.
Oh, okay. Chalo.
I can try in Hindi, sir. I can try in Hindi.
But if it is comfortable for you with English, you tell in English. I thought you may be okay.
Sir, जब like PCB मतलब जब प्रोग्राम रनिंग स्टेट में है एक टाइम तक ही रहेगा, उसके बाद नेक्स्ट प्रोग्राम को एग्जीक्यूट होना है, नेक्स्ट सेट ऑफ इंस्ट्रक्शन. नाउ दैट प्रोग्राम इज इन द रेडी स्टेट and that needs to give input again after one cycle of that process is complete. So फिर से वो क्या input देगा ताकि वो run हो, फिर से CPU क्या process करेगा, that information is stored in PCB.
Right. That information. So while a process going from running state to ready state or running state to waiting state, the up-to-date information of that process will be kept in that personal diary. That is, the personal diary is the PCB. The moment a process gets from running state to ready state or running state to waiting state, its PCB will be updated. PCB is the personal diary. उसमें वो update हो जाएगा, such that when again it will come to running state, those information can be reused. ठीक है, Ishan, very good. You please all, I am telling you to all, you please go through this thing idea कि क्या मैंने बोल रहा था और ईशान क्या बोला. Of course we will have that next day again, the same discussion will be continued, because this is a very fundamental thing of computation and operating system. If this part is clear, this is a very conceptual part. If this part is clear, the process scheduling, process management, the entire thing will be clear to you. Okay, if this concept is clear, nothing to memorize, कुछ memorize करने का जरूरत नहीं है. Just दिमाग में लगाओ कि एक process नया, it is coming in नया process. So the moment it comes, it may not get the CPU, because CPU may be used by some other process. So it will be kept in a ready state. When the CPU gets free, it will come from ready state to running state. While it is in the running state, it may ask for some input-output device. So it will be going to waiting state for the completion of the input-output operations. Once the input-output operation is completed, it will be going from waiting state to ready state. Again from ready state, it will come to the running state for further execution or further getting the CPU cycle. Once the process is completed, it will be terminated. So terminated means it will produce the result and will delete the PCB allocation, because PCB is a data structure. So that data structure will be deleted from the memory such that that space can be used by some other processes.
Sir, in which memory is the PCB stored?
See, it should stored in the main memory, because the is the faster device. or you can say cache memory. If it is a very frequently used, depending on the frequency it is being accessed, operating system may keep that in a more faster memory in the cache. Rather, otherwise it will be in the main memory or RAM. ठीक है? चलो पहले, yeah.
Sir, one question, sir. Will we get the slides to this, sir?
Yeah. I mean, already I have uploaded everything in Moodle. I mean, সবকিছু কিন্তু Moodle. For my last 2 lectures, already they are in a Moodle. You will get the lecture in Moodle. So today's lecture I will also upload in a Moodle. Don't worry about that. ठीक है?
Okay.
And of course the slide. Slide I can give the entire zip slide to you. So it contains the all chapters. ठीक है? These are freely available. These are Galvin book slide, which I told.
Okay, sir.
चलो तले.
Thank you.
Okay,
Thank you, sir.
Thank you, sir.
देखो कोनो असुविधा होला. Okay, so be very clear. If you have any doubt, please उसको दबा के मत रखना. ठीक है? So don't confuse with your language. कि sir हमको English नहीं आता है. How can I speak if somebody is laughing on you? You tell it to your own language. Except this Telugu, Malayalam, you can speak easily in Hindi with me. Bengali, of course. Even Uriya, Asamiya, you can use. At least I can understand. Okay. So don't make the language as a bar.